Convert the following equation from slope-intercept form to point-slope form. First, let's just recall what slope-intercept form and point-slope form look like. Slope-intercept form looks like y equals mx plus b, where the m stands for the slope of the line and b stands for the y-intercept of the line. Point-slope form looks like y minus y sub 0 equals m times x minus x sub 0, where m stands for the slope and x sub 0 and y sub 0 are the x and y coordinates of any point on the line. So, the equation y equals negative 6x plus 3 is in slope-intercept form. The slope of the line is negative 6, and the y-intercept is 3. In order to write it in point-slope form, we need to know two pieces of information. First of all, the slope, and second of all, a point. Now, we can find the coordinates of many points on this line, y equals negative 6x plus 3, but perhaps the easiest point would be the y-intercept itself, which would be 0, 3. And we know that the slope is negative 6, so to write this line in point-slope form, it would be y minus the y-coordinate of the point equals the slope times x minus the x-coordinate of the point. So that would be one possible version of the line y equals negative 6x plus 3 in point-slope form. But we could come up with other equations that are equivalent to y equals negative 6x plus 3 in point-slope form. For instance, let's find a different point than the y-intercept. We can choose pretty much any value for x that we want. I'll choose, x equals 13, since that's my lucky number. And I'll find the y that goes with that. So when x equals 13, y equals negative 6 times 13 plus 3. Now, let's see here. What is negative 6 times 13? That would be hold on. That would be what? Negative 60 minus 18, so that would be minus 78 plus 3. And negative 78 plus 3 would be negative 69. So, that means we have the coordinates of a point, which are 13, comma, negative 69. So, we can take our y-coordinate of the point. We'd have y minus negative 69, which is the same as y plus 69, equals the slope, which is negative 6, times x minus 13. And in fact, all three of these forms of the line are equivalent. Though they look different, if you were to graph them, you would get exactly the same line. So we started with this equation in slope-intercept form, and we came up with two possible versions of the equation in point-slope form. Now, why don't you take a moment and see if you can put y equals negative 2/3 x minus 10 in point-slope form. Pause the video and then restart it when you finish the problem. So, the equation y equals negative 2/3 x minus 10 tells us that the slope of this line is negative 2/3. And the minus 10 is the y-intercept, so the coordinates of that point would be 0, negative 10. So, probably the easiest point-slope form equation of this line would be y minus negative 10, or y plus 10, equals negative 2/3 x, or negative 2/3 times x minus 0. Now, if you want a little bit more of a challenge and you don't want just to use the y-intercept, we could use some other point. Let's just pick a value of x. I'll pick a multiple of 3 so as to avoid a fraction. So let's say when x equals 9, y would be negative 2/3 times 9 minus 10. Negative 2/3 times 9 would be negative 6, minus 10 is negative 16. So, when x is 9, y is negative 16. So here are the coordinates of a point on our line. So, we can use point-slope form again. We would get y plus 16 equals the slope, which is negative 2/3, times x minus 9. So those are two possible answers. There are really an infinite number of possible answers. You can just come up with other answers by picking a new value of x and finding the corresponding value for y, and then plugging in the point for point-slope form. So to conclude, number 2 says, write your best strategy for the steps you need to take in general to convert from slope-intercept form to point-slope form. So, first, determine the slope. If you're given an equation in slope-intercept form, the equation will look like y equals mx plus b. So, determining the slope is as easy as finding the coefficient of x. Next, find the coordinates of any point on the line. To do this, we can choose any value of x that we want, substitute it into the equation, and calculate the y. Once we know the y, we'll have the coordinates of a point. And once you know the coordinates of a point, we can write the equation in point-slope form, which looks like y minus y sub 0 equals m times x minus x sub 0. So, in step 1, we determine what the m is in point-slope form, and in step 2, we determine the coordinates x sub 0 and y sub 0, and then it's simply a matter of substituting in, and then we will be done, and we've converted an equation in slope-intercept form to an equation in point-slope form.